Here's an example in which we're given cosine of theta and sine of theta some information. I'll write that better for you. Determine the exact values of sine, cosine, and tangent. So let me make this a little better. What this is really saying here is that the sine of angle theta is less than 0. Less than 0. And the cosine of theta is 3/4. And they're asking me to find the sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Okay, so this is going to be a lot of work. So step number 1, find the quadrant by using all students take calculus. What am I talking about? Well, if I come up here, I draw a little coordinate system, and remember how the signs work. All students take calculus, right? That's how you know which trig functions are positive in which quadrants. They're all six of the trig functions are positive in the first quadrant. S, what does that stand for? Sine, and of course his upside down, which is cosecant, are positive in the second. The other 4 are negative. And T is tangent, and his upside down, cotangent, are positive in the third quadrant. The other 4 trig functions are negative. And in the fourth here, cosine and his upside down, secant, are positive in the fourth quadrant. The other 4 trig functions are negative in that quadrant. Okay, so they're all 6 positive in the first quadrant. Only sine and cosecant are positive in the second. Only tangent and cotangent positive in the third. Only cosine and secant positive in the fourth. Okay, so what? Well, we got to find which of these 4 quadrants we're in. Well, here's how we do it. They're telling us that the cosine of theta, find theta's quadrant. The cosine of theta is positive 3/4, right here. So cosine's positive. And sine of theta is less than 0. What does less than 0 mean? Negative, right? Things less than 0 are negative. So where is sine negative? Not here. They're all positive there. And sine is positive there. So it can't be those 2 quadrants because sine is negative. And cosine is positive, so we got to be in the fourth quadrant. Fourth quadrant where cosine is positive and the other 4 are negative, including sine. Why aren't we in the third? Well, in the third, tangent and cotangent are positive, but the other 4, sine, cosine, secant, cosecant, are all negative, aren't they? And that's not right. Cosine's supposed to be positive. So we're not in that quadrant because cosine's supposed to be positive. So we're in the fourth quadrant where cosine is positive and sine is negative because the other 4 are negative, and that's right. Sine is negative, cosine is positive. So by using the all students take calculus, we found quadrant 4. So theta is in quadrant 4. We found that. So theta's in quadrant 4. So draw your triangle from the origin to the x-axis. So now that we know it's really quadrant 4, let's do it. I'm going to draw my triangle from the origin to there. No, that'd be the y-axis. That's not right. I want to draw it from the origin to the x-axis, like that. This is the x-axis. This is the y, as you know. Why? Why do we have to go to the x? Because that's where 0 degrees starts, right? When they set up the angles, they started 0 degrees at the positive x-axis. They could have put 0 straight up. It was just a choice. But they put it on the right, so we've got to make our triangles go to the x-axis. Why? Well, that's so that, because here's the real angle. Angle theta really starts at 0. All angles really start at 0 and goes all the way to there. That's really angle theta. But we're going to put angle theta right here. It's really, we're going to call it theta. It's really theta's reference angle. And why we can do that is because as long as you go to the x-axis, see how that angle is going? We don't want to go here to the y-axis. But as long as you go to the x-axis, the theta reference angle will have all the same answers for sine, cosine, tangent as the original real angle theta, which really comes from 0 degrees. So that's how we do these. We put a reference angle inside the triangle, and it'll have all the same answers as long as that reference angle goes to the x-axis, because all the angles started from the x-axis at 0 degrees, so it'll work. That's why we have to go to the x-axis and not the y. All right, step 3. Find two sides from our friend's SOHCAHTOA. So find two sides. Okay, so this is the opposite, right? It's opposite of theta. This is the adjacent. This is the hypotenuse. So what do we got up here? We've got cosine. Cosine is 3/4. Cosine is adjacent over hypotenuse. So that means adjacent is 3, hypotenuse is 4. So the adjacent is 3, hypotenuse is 4. Let's do that. Adjacent is 3, hypotenuse is 4. Good. And that is a positive 3. The hypotenuse is always positive. But the right, left, up, and down, they depend on which direction you go. So from here we go right and we go down. So this one's going to be negative when we get, this is going to be a negative number when we figure out what it is in a minute. But this one's positive because it's right. The hypotenuse is always positive because that's just a distance coming out of the origin. We only do the positive negative for the right, left, up, down. You know, right is positive, left is negative, down is negative, up is positive kind of thing. So from the origin, to get to this angle, we got to go right and down. So positive and negative. And the hypotenuse is always positive because that's just our angle coming out of the origin. Okay, so find the two sides. Correct signs. We got it. So now step 4. Find the third side from, you know, the Pythag, right? A squared plus b squared is c squared. So let's do it. So I'm going to go a squared plus b squared is c squared. Which one's c? C's right here. C's the hypotenuse, isn't it? Always the hypotenuse. That's my 4 squared. A and b, the order doesn't matter. I'll just go 3 squared plus b squared. It doesn't matter which way you do it. So that's going to be 9 plus b squared is 16. Subtract 9 from both sides. B squared is 7. Root it. B is the root of 7. So let's come back here. And now I know this is negative the root of 7. As we said, it's negative because, again, this is right and down. So this side is negative root of 7. So this part just came out root 7, but I knew it was negative because spatially in the triangle, it's right and down. It's got to be negative. The other one's got to be positive because it's right. All right, you've got it. So now you get the third side. Now step number 5. Find the sine, cosine, tangent, again from SOHCAHTOA. Okay, so we can find everything in this triangle now. Here we go. So we're going to find the sine of angle theta. What's the sine of angle theta? We'll just go to the triangle. You know sine is opposite over hypotenuse. So opposite hypotenuse, negative root 7 over 4. Good. Cosine of theta. What's cosine? Adjacent over hypotenuse. Adjacent over hypotenuse. Adjacent over hypotenuse. Plus 3 over plus 4. And finally, tangent. What's tangent? Tangent is TOA. Opposite over adjacent. Negative root 7 over 4. Over 3, I mean. TOA. All right, so we've got those 3. And you can double check their signs just to make sure. Remember the all students take calculus thing we talked about in the beginning? Right, up here, we are in this 4th quadrant. So only cosine is positive. Sine is negative, tangent should be negative, right? Because in the 4th quadrant, all students take calculus, cosine, and his upside down function, secant. Those two should be positive. The others are negative. So sine and tangent should be negative, cosine should be positive. Right. Sine and tangent are negative, cosine is positive. Perfect, good, double check. So I'll write, well, I'll just leave that. Well, I'll write double check your signs by all students take calculus. Okay, now those are all, that's sine of regular theta, cosine regular theta, tangent regular theta. Now we're ready for what they're asking. They're asking the sine of 2 theta, cosine 2 theta, tangent 2 theta. How do we do that? Well, we are going to now need to, come on down, and on step 6, we're going to use the double angle formulas. So we found these 3 things, so that now we could use the double angle formulas and get our answers. Okay, so let's go down to the double angle formulas. So if you go down to the formulas here, start with the sine. Sine of 2x, sine of a double angle, is 2 sine of the regular angle times cosine regular angle. Let's go to it. So it's going to be, so sine of 2 theta is going to be 2 sine regular theta cosine regular theta. So that's going to be 2. What's the sine of regular theta? Well, it's right here. That's negative root 7 over 4 times the cosine of regular theta, which is right here, positive 3/4. Okay, you know how to work that out, right? Put the 2 over 1 whole number, multiply straight across the top there. It's going to be negative because you have one negative sign. 2 times 3 is 6, root 7. 4 times 4 is 16. See that? I went 2 times 3 to get 6. Root 7. That 7 needs to stay in the root, and the 2 times 3 is 6. Those guys are outside the root. They stay outside the root. And 1 times 4 is 4 times 4 is 16. Now I can reduce that. Divide by 2. Divide by 2 leaves what? 3 and 8. So our answer is negative 3 root 7. I'm running out of room a little bit here. Negative 3 root 7 over 8. There we go. There's the sine of 2 theta. Negative 3 root 7 over 8. Okay, I'm going to move it down here. It just doesn't look good there. Negative 3 root 7 over 8. There we go. So we've got the sine of 2 theta. Now, let's go on and get the cosine of the double angle. How are we going to do that? Go get the double angle formula. What does it say for cosine? Cosine of 2x is cosine squared minus sine squared, right? Cosine of double angle is cosine squared of the regular angle minus sine squared of the regular angle. So, here we go. Cosine squared of the regular angle minus sine squared of the regular angle. And so what is cosine of the regular angle? Again, it's right here. Plus 3/4. So plus 3/4 squared. And then what's the sine squared of the regular angle? Sine of the regular angle is right there. Minus root 7 over 4. Squared. Okay, so that's 9/16 minus. This is going to become positive regular 7 over 16. You okay with that? I squared that root and that canceled it, and I squared the 4 to make 16. So the 7 stayed 7 on the top because the root right here blocked the squaring. And so then 9 minus 7 is 2, and this negative became positive, right, when you squared it. 2/16, that's just 1/8, isn't it? So that cosine 2 theta reduced like that. Finally, last step, tangent of the double angle. So there's the cosine of the double angle. Tangent of the double angle. Let's go down and get the tangent double angle formula. Tangent of a double angle is this, 2 times the tangent of the regular angle over 1 minus the tangent squared of that angle. 2 tan over 1 minus tan squared. So it's 2 tan over 1 minus tan squared. All right, 2, what's tangent of x? Well, tangent of regular x is right here, minus root 7 over 3. Over 1 minus root 7 over 3 squared. Make sense? We're finding the tangent of 2 theta by the tangent of, well, this actually be regular theta. I called it x, whatever. So here we go. What happens here? Put the 2 over 1, multiply straight. That's negative 2 root 7 over 3 all over 1 minus. You just square that negative, it becomes positive the root actually gets canceled 7 over 9, right? You square the root cancels and the 3 becomes 9. The 7 stays 7 because the root was canceled instead of squaring the 7. All right, and so what do we get then? This is negative 2 root 7 over 3 over, what happens on the bottom? This is a long problem. I need another paper here. On the bottom, this is 1. 1 is over 1, multiply top and bottom by 9 to make a common denominator. 9/9 minus 7/9, right? And so this is going to be minus 2 root 7 over 3 all over, what's that denominator become? 2/9. You tracking with me? 2/9 down there equals, this problem is never ending, we're almost there, negative 2 root 7 over 3 times, you grab the denominator, flip it up, 9 over 2, right? Because dividing is upside down multiplying. So the way you divide by a fraction is you flip it and multiply by the upside down. Now how do you do that? You cross cancel. 3 goes into 9. 3 times 2 cancels 2. Minus 3 root 7. Everything else is canceled. Whew. There it is. The exact value for the tangent of 2 theta. So we found them all. It was a lot of work. What did we have to do? From the beginning, we had to find the right quadrant using the all students take calculus, right? They told us sine is negative, less than 0, and cosine was positive 3/4, so it's positive. So that had to be quadrant 4. The all students take calculus is only satisfied in quadrant 4 where cosine's positive and the other ones are negative, so sine is negative. Then we drew our triangle in quadrant 4 to the x-axis, put our angle in there, used SOHCAHTOA to find 2 sides, found the third side with the Pythag. Then we used SOHCAHTOA again to find sine, cosine, and tangent of single theta within the triangle there in the 4th quadrant. Double checked our signs using all students take calculus. Sine and cosine, sine and tangent were negative, cosine was positive, was perfect. And then to find the double angle, now we use the double angle formulas, plugged everything in for sine 2 theta, cosine 2 theta, tangent 2 theta.